Welcome back. Today we're going to talk about electrostatics. So here we're given two spheres, sphere R and sphere S. So sphere R is positive 8 microcoulomb and sphere S is negative 4 microcoulomb. So the first question says, explain why the spheres were placed on wooden stands. So they place the spheres on wooden stands just to prevent the charge from leaking. So we are going to say 1.1 to prevent the charge from leaking to the ground. So they place the spheres on wooden stands just to prevent the leakage of charges. So that's the reason why they place them on wooden stands. Now the second question, they are saying sphere R and S are brought into contact for a while and then separated by a small distance. So what you should know is, once the charges were brought into contact, when they get separated, they form a new charge. That means when they get separated, the charges or the spheres are going to have new charges now, which is only one charge. So this is how we calculate a new charge. So this is a new charge since the charges were brought into contact, or the spheres were brought into contact. So we have two spheres, 1, 2. So it's charge 1 and charge 2. Now, since there are 2, we divide by 2. So the first charge is 8 plus the second charge is negative 4. Then we divide by 2. Now it's 8 minus 4, which is 4, divided by 2. So 4 divided by 2 will give us 2 microcoulomb. So it means what? Now the new charge on each sphere is 2 microcoulomb. So it's charge R, or charge on R is 2 microcoulomb, and the charge on S is 2 microcoulomb. That is a new charge on each sphere now, because they are brought into contact. So the following question, they say, draw the electric field pattern due to the two spheres R and S. So since now the spheres or the charges were separated, now they form a new charge. That means now we deal with a new charge. So it means the electric field pattern we're going to draw is based on a new charge now. So 1.3, let's say we have two charges. This is S, this is R. Since they are both positive, that means they are going to repel each other. They are going to repel. They don't attract these ones, since they are like charges. They repel. So since it's positive, the direction of the electric field is out. It's going out like this. The direction of the electric field is going out in both charges, just like that. So they repel. Remember, it's a new charge. That's why it's positive. Let's say positive. So they're both positive, then they repel each other. Then now we have a second statement that says, after R and S have been in contact and separated. A third sphere T is charged or of charge. Positive 1 microcoulomb is now placed between them, as shown in the diagram below. So we see the distance between R and T is 10 centimeters. The distance between S and T is 20 centimeters. Now, the question says, draw a full body diagram showing the electrostatic force experienced by T due to sphere R and S. So, as you can see, T is positive, and R is positive and S is positive. So it means what? 1.4. The full body diagram, remember, the full body diagram will represent the object with a dot. So let's say this is T. Then, looking at T and R, since R is positive as a new charge, remember, R is positive as a new charge and S is positive as a new charge. Now, let's say T is here. This is our full body diagram. This is T. Remember, we're talking about T due to R and S. So, now, we are saying T and just like that. So it means what? This is the electrostatic force S on T. Why? Because S is pushing T to that side, and then this is the electrostatic force R on T. So it means what? Since T and R are positive, R is pushing T to this direction, and the S is pushing T to that direction. They repel. Remember, they are all positive. So T here is being pushed by R to this direction, and the T here is being pushed by S to this direction. So this is the full body diagram that they want. Now let's move to the following question. They say now calculate the net electrostatic force experienced by T due to R and S. So let's open a new page. So now the question is 1.5. They say we should calculate the net electrostatic force. Remember, net is the total of electrostatic force experienced by T due to R and S. So it's for 6 marks. It means something. Then we have the formula that says F, as for electrostatic force, is equal to, there is K, charge 1, charge 2, all over R squared. So this is the distance between the charges. This is the electrostatic force. This K is the constant. So now for K, we know K as 9 or 9.0 times 10 to the power 9. And then charge 1, it can be T or it can be R. Let's say now it's electrostatic force F R on T. Let's say this one's R on T. So now R is 2. Remember, we got a 2 as a new charge, so R is 2. Remember, it's microcoulomb. Now we have to convert the microcoulomb to coulomb. So how do we convert this? We say it's plus 2 times. Remember, microcoulomb is 10 to the negative 6 now in coulomb. So it means we have 2 times 10 to the negative 6. S for T is 1 times 10 to the negative 6 all over the distance between R and T, 0,1 squared, y 0,1, because we are given 10, remember, 10 divide by 100, so it's 10 centimeter. From centimeter to meters is 100, so we divide by 100, that's where we got 0,1. So now it's in meters, just like that. So now we have 0,1 squared. So from the calculator, let's punch the calculator. Okay, we get 1,8 Newton. So let's check. From the free body diagram, it says T on R is right, or R on T, I mean, it's right. It's going to the right. That means the direction of the electrostatic force is going where? To the right. Now, let's see, now we're going to calculate the electrostatic force S on T. So S on T is equal to K charge 1 charge 2 divided by the distance squared. So since we have K is 9.0 times 10 to the 9, remember S is the same as R, so it's 2 times 10 to the negative 6, and then for T is 1 times 10 to the negative 6, all in all now is 0,2 squared. Why is 0,2? Because the distance is 20, we are given 20 centimeters, so we convert 20 centimeters as 20 divided by 100, so that's where we got 0,2 in meters now. So now let's punch the calculator. And from the calculator we get 0,45 Newton. So we check our free body diagram now. S on T is where it's left, is going to the left. So the direction it should be left. So that's the direction of the electrostatic force at S on T. So now the F net, since they said we should calculate the net electrostatic force, so the F net now is equal to the electrostatic force R on T plus the electrostatic force S on T. So the electrostatic force R on T, we got 1,8 Newton, so it's 1,8 Newton plus the electrostatic force S on T, remember it's left, it's going to the left, that means it's negative 0,45 Newton. So from the calculator, what do we get? We got 1,35 Newton. Since it's positive, it means it's going where? It's going right. So that's where we chose right as positive. So this is how we calculate the net electrostatic force.